MacScan is a real-time CV scanning tool, which will scan packages and libraries downloaded on your bare metal, virtual, or cloud Macintosh machines. You can run it right along your developer workflows, or even within your CI/CD automation pipelines. The first feature is the real-time scan. This scan will sit in the background and watch file system events. If a gem package, for example, changes and a new version is downloaded, it will show the version, the package name, the CVE, its score, and its severity. The next feature is the full scan. This can be run before or after you make major changes in your application and will show the changes just like the real-time scanner would. MacScan is very developer friendly. The real-time scanner, for example, doesn't impact the performance of any running workloads on your machine. You can use the CLI, or you can make curl calls to the REST API to execute your scans and even get the results back. We support both Intel and Apple Silicon architecture. In today's example, I'm going to show you the performance impact of MacScan, doing a background scan and then also a full scan. I need a project in order to show changing dependencies, so I'm going to use Kickstarter's iOS OSS project. It's a public repo, so you can find it online and use it yourself. Our documentation shows how to install MacScan, and then also how to run the full scan as well as the real-time scan. You can find this at docs.virtu.com/mac-scan. Let's get started. I'm going to pull up my terminal here. In the top left, I'm CD'd into the Kickstarter iOS OSS project. Right below that, I'm going to show vulnerabilities from the MacScan CLI report vulnerabilities, and I'm going to sort them by severity. So the most severe items show at the top. Below that, I've got a tail going, a live tail of the MacScan log, just to make sure that it's doing what I expect it to do. In the top right, I've got htop running. This is showing any Xcode processes as well as the MacScan processes. You can see that MacScan isn't really using any resources currently. And then finally, right below that, I've got a terminal where I will run the MacScan CLI commands. So let's get started. What I want to do is I want to check the status of MacScan. It's currently active, but the background real-time scanner is not running. So let's make sure that that's running. There we go. It's now running. You can see that there still isn't really much activity, as there aren't many file system events happening for it to scan. Let's go ahead and run make build. And you can see that the MacScan process starts using a little bit of CPU, but not much. You'll see it jump several times to about a CPU or two, maybe even 3 if it's getting a lot of packages. In the bottom left, you can see that the logs are actually showing that it's capturing a lot of packages, a lot of changes. There's several thousand changes happening. And right above that, you can actually see it's already caught a lot of vulnerabilities. There's git gem vulnerabilities, there's Artifactory, there's an npm vulnerability, and then there's CocoaPod downloaders. These are very high severity, so these are what I would want to triage first. You can see that the usage still really isn't much. You can see that Xcode is performing lots of heavy usage. Almost every CPU is being used. But MacScan still isn't really using much. We've run this many times. We've gotten averages, and we show that actually there's really no significant difference running MacScan in the background when you're doing your builds or your tests. Let's wait for the build to finish, and then we will run a full scan. There we go, the build finished in less than 4 minutes. It's exactly what we expected. Great, so let's clean up the report and then run a full scan to show the results of that. Let's go ahead and stop the real-time scanner. And then we're going to run full scan. Great, so you can see in the log that it started scanning slash. This might take a while, but you can see that really the CPU usage stays around 1 CPU. You can see that the full scan usage is really only 1 CPU. This shouldn't interfere with your everyday work. You can run it any time that you want. There's many options here for the report output. You can change the report format to actually show JSON. This makes it very easy to consume with third-party tools that are prepared to consume JSON. This will show the path for the package, versions, and any other information that these tools might need. The REST APIs as well have the ability to curl for that same output. Great, so it looks like it actually finished cataloging all packages on slash. It found actually quite a lot of vulnerabilities. And the CPU really didn't go past the CPU and a half total. You can see that the results are here. Most of them, gem vulnerabilities at the top. You've got some Java vulnerabilities as well. These are things that I can work with my security team to determine whether or not they're significant vulnerabilities. The full scan of my entire volume only took about 4 minutes too, which is what we would expect. Wonderful, so I hope you've enjoyed this demo. You can get information at veer2.com/macscan, as well as our documentation site, docs.veer2.com/mac-scan. Feel free to reach out to support@veer2.com. That's VEERTU.com.